Let's start with a question that puzzled scientists for centuries. Is light a wave or a particle? It turns out the answer is both. This phenomenon is known as wave-particle duality, one of the cornerstones of quantum mechanics. In the 1600s, the famous scientist Isaac Newton believed that light was made of tiny particles or corpuscles. This made sense based on how light behaved in experiments. But about 100 years later, another scientist, Thomas Young, conducted a groundbreaking experiment called the double-slit experiment. Young's experiment showed that light didn't behave like tiny particles at all. It behaved like a wave. So, for a while, scientists thought light was purely a wave, like ripples in a pond. The double-slit experiment is fascinating. Imagine shining a beam of light at a barrier with two narrow slits. On the other side of the barrier is a screen. If light were made of particles, you'd expect to see two bright spots where the light particles pass through the slits. But instead, what appears on the screen is an interference pattern, a series of bright and dark bands, similar to the patterns formed by waves of water overlapping. This pattern was a clear indication that light was behaving like a wave. But wait, it gets even stranger. In the early 20th century, scientists, including Albert Einstein, discovered something mind-blowing. Light also comes in little packets of energy called photons. So, light behaves like a wave and a particle at the same time. This dual behavior is the essence of wave-particle duality. Here's where things get even more bizarre. In 1924, French physicist Louis de Broglie made a bold suggestion. He proposed that not just light, but matter could behave like waves too. This means that things we think of as solid particles, like electrons, can sometimes act like waves under certain conditions. When scientists tested de Broglie's idea by firing electrons, tiny particles that make up atoms, through the same double-slit setup, they were shocked to find that electrons also created an interference pattern. This showed that even particles of matter have wave-like properties. Einstein, who won his Nobel Prize for his work on the photoelectric effect, was one of the first to propose the idea that light could be understood as both a wave and a particle. This was a monumental step forward in quantum theory and set the stage for many of the quantum concepts we'll explore in this series. The discovery of wave-particle duality was revolutionary. It changed how we understand the universe at the smallest scales. Now let's break it down with an example. Imagine trying to catch a baseball. You know the path it will take through the air. But at the quantum level, particles like photons or electrons don't follow such predictable paths. Instead, they act like waves, spreading out and interfering with themselves, creating patterns that make predicting their exact position almost impossible. So, what does wave-particle duality tell us about the world? It reveals that the universe is far more complex and mysterious than our everyday experiences suggest. At the quantum level, particles don't follow the rules we see in the macroscopic world. Instead, they live in a strange, probabilistic world where they can behave like both particles and waves. Wave-particle duality is more than just a quirky idea. It forms the foundation of technologies we use today. Quantum computing, for instance, takes advantage of the wave-like properties of particles to process information in ways classical computers cannot. Even technologies like MRI machines and lasers rely on quantum principles rooted in this duality. And it doesn't stop here. In our next video, we'll explore one of the most famous and puzzling principles in quantum mechanics, Heisenberg's uncertainty principle. It tells us that the more precisely we know a particle's position, the less we can know about its momentum. This principle fundamentally challenges how we observe and understand reality. Quantum mechanics is full of surprises, and wave-particle duality is just the beginning. Stay tuned for more mind-bending discoveries.